say after this nice discussion, everything what I was thinking about this meeting has already said. When I was asked to give the summary and the conclusion of this meeting, I was very much surprised because I was never doing research in aging. But I took it as a challenge because I came here and I told to Josiane I come to this meeting to learn something. So let's see whether I have learned something. So when I came here, I did not much more than the theory of. This is just the pointer. Okay, so the theory everybody knows, and so I understand here that we have some aims at this meeting to discuss and to show some results on, and this is to understand the mechanisms of the aging processes and how they can be influenced. And this is a prerequisite to develop strategies to delay senescence and to increase lifespan. And at the same time, we want to prevent age-dependent diseases like cancer, dementia, muscle atrophy, cardiovascular diseases, and so on. So we had some aims, and we want to meet these aims, and we had some strategies to how to come to these aims. And the first question we had, what is...
Is it okay?
Yeah.
Yeah?
What is the mechanism how cells do age? And according to this theory, it was oxidation. But I learned at this meeting that it's not just oxidative stress as such, but rather by the downregulation or by the blocking or by the impairment of processes which normally counteract these oxidative processes, which counteract the accumulation of damaged molecules, and all these processes finally lead in the aging, finally lead to the inability to handle the physiological stress. So even the physiological stress cannot be handled, and this leads to the accumulation of the damaged proteins. And reasons for the accumulation and for the changes in the aging cell are changes in redox states of cells. You have heard the talk of D. Jones. Antioxidant or defense systems are downregulated. You have an impairment in the proteasome called, we learned from the talk by Karen David and Statis Konos. We have a decrease in the phase 2 enzyme expression, and this is regulated by the factor NRF2. We have a decrease in repair enzymes, including the methionine oxide reductase. This was a talk of Isabel Petropoulos. And we have a lot of talks about mitochondrial dysfunction from several people. Next, please. So the longevity can be increased, and the age-related disease can be decreased by caloric restriction, and this can extend the average and the maximum lifespan, I learned. And we can do this by exercise, and with the exercise we can increase the average lifespan only and not the maximum lifespan. Next slide, please. The mechanisms which have been discussed were in caloric restriction. This mediates ROS production, to my surprise. It mediates SIRT activation by NADH, so ADP ribosylation of proteins, and by the NADH ratio. And the targets which are affected by SIRT are NF-kappa B, the FOXO, P53, DNA repair enzymes, cell cycle control enzymes, apoptosis, inflammation, and so on. And we had several talks on these topics. Another mechanism is for the decrease in insulin or insulin growth factor signaling, and this was discussed in many talks. And there was a big discussion because all these authors had several different opinions about this topic, and sometimes the outcome was contrasting. I will come to back this in the next before the slide. And back please.
No.
It can also be obtained by methionine deficiency or by deletion of TOR. And the caloric restriction counteracts with mitochondrial dysfunction, which is also an event present in aging cells. Next slide, please. So the mechanisms of the exercise is also ROS production. The exercise should be moderate, or this should be in the training phase. And by the ROS production, the adaptation to enzymes of the adaptive response to stress. Superoxide dismutase, catalase, heat shock proteins are induced in young but no longer in old animals. And what we also have learned that the delay of muscle atrophy can be, or the exercise can delay the muscle atrophy in old animals. And the exercise can prevent the damage which is caused by exhaustive exercise. So we have, during the training phase, an upregulation of our protective systems, and to protect the body for the damaging radicals probably be produced during exhaustive exercise. And I always say that this reactive oxygen species is kind of vaccination to protect or prepare the organism for the next stress, which might be much greater or much bigger than the moderate stress. Next slide, please. So we also have nutrition, and we try with the nutrition or micronutrients or secondary plant factors to improve the health or doing a lot of protective processes. And we have heard about flavonoids, about glucosinolates, about resveratrol, and of course about essential micronutrients. And with the aim to upregulate endogenous defense system to counteract disease development and to optimize health. And with this, all these nutrition factors, we come to our next problem or interesting topic about the intervention and or the treatments. When should we intervene and with how much should we intervene? And this is the problem of hormesis, and this is also was discussed by Vittorio Calabrese, and we have also heard in the panel discussion about this. This means that low amounts of micronutrients, for example, can do harm for the organism, and an adequate amount is okay, so it has beneficial effects, and if you have a too high amount, so they can induce damage again. To solve this problem might be the triage theory of Bruce Ames might help. Is Bruce here? So I try to understand what it is. So the nature has developed this strategy to make a selection which of the proteins or the genes or the processes have to be maintained when a certain nutrient becomes limiting. So these are maintained, and other part of these proteins are no longer synthesized or expressed to guarantee the survival, even at the expense of later disease development. So if we in young age have a lack or deficient of certain micronutrients, so we might develop diseases later in the life. So the challenge is, what are these dispensable proteins? I can only say something about selenoproteins, and we know that there are how they call it, dispensable proteins and indispensable proteins. And at a low selenium content, for example, the glutationium peroxidase 1 is eliminated at once, and the organism does not have any harm of it unless it is stressed. So under normal conditions, we have a set of proteins which we can get rid of without consequences. Next slide. To learn about what these proteins are, we need biomarkers, and we need readout systems. And this is the problem we have to define what is a healthy diet, what is a healthy state, and how can we be 100 years old in a healthy state. Next, please. So it is always nice to have a common denominator so we can look at. And the transcription factor, which was mentioned very often, was the transcription factor NRF2. And this NRF2 is activated by reactive oxygen species, is activated by compounds which modify thiol groups, and it's also activated by inflammatory prostaglandins, for example. This NRF2 induces or regulates phase 2 enzymes. It regulates proteasome in a non-protease, and this is something which I learned and have never heard before. Very new and very interesting finding. And the NRF2 also regulates repair systems. So NRF2 might be one of the key pathways or compounds which can be a target to measure whether we have a healthy state. Next, please. So, what are the strategies to live longer in a healthy state? So, I try to figure out something. I think we have to accept that reactive oxygen species and probably also nitric oxygen species are not always damaging, but they have indispensable physiological function. So a little bit stress is beneficial, like the vaccination I have mentioned already. And that means we should come away from the high doses of antioxidants which we are suggested to eat every day. So then, as usual, do a moderate exercise regularly, not only once a week, might be sometimes more a week. And don't eat too much, but return to a balanced diet. And this is what the nutritionist always suggests. So we have to return to a balanced diet. We have to eat everything, a little bit from everything, and we have to have the combination unless we know whether there is one thing in the diet which does the beneficial things we want. And I was very happy to learn that also the wine is part of the balanced diet. So. And this balanced diet should be eaten from the beginning, and it has to be, and this makes the story very complicated now, has to be adapted to the personal, to the genetical, to environmental and personal situations, so we cannot give global suggestions that we have to do everything all the same, so we have to consider in which situations we are. Next, please. So, I did not mention the wonderful talk by Roberta Brinton. She has found some novel findings about estrogens in Alzheimer's disease, so I would like to keep you informed about this. Thank you very much. So I did not find where I put you in all these drawers I have created. And we also had the young investigators, maybe you have heard of them, and the time was too short to bring everything into this drawers I made, but I have learned that there are very novel and nice mechanistic and instrumental systems, so might be for next meetings the young investigator presentation should be in the middle of the meeting, not at the very end. So next slide please, and I think this is the last one. And I will end with a sentence which was one of the first sentences in this meeting, and this was given by Claudio Franceschi, and he said aging is a complex trait. So we know this, and I have learned that this is more and more complicated, and with this I want to thank everybody for you being here, for Josiane and all your co-workers for this wonderful meeting. So I have learned a lot, although I might not be the expert in the meantime. And what I also want to do, I want to wish Helmut his best recovery, a very fast and a very complete recovery, because I had to give this talk for him, because he cannot be there. So thank you very much. So, thank you very much.
Thanks everybody, and of course especially the speakers who make the success of this meeting. Thank you very much. I hope to see you in a further, dans l'avenir. Voilà. Thank you.
Club of California, Lester Packer, Enrique Cadenas, and myself, and all of our friends. We want to thank you for such an outstanding job. We've all learned so much, and I have tears in my eyes. I have to go home now. Thank you all.